So in this present series which we are going through, that is titled as Advanced Data Structures and Algorithms, and the present topic which we are digging into is about the vectors, which we have started as an example of data structures available in your standard template library as far as C++ is concerned. So in the previous lecture we have gone through with the concept of some list, and we have also seen what is an iterator, and we started with the vector. And now in this lecture we are going to look into basic operations which are available with this kind of vector data structure. So any kind of data structure, if we talk about the first basic operation, apart from insertion and creation that comes into our mind is accessing the elements. Insertion and creation, the 8 ways of creation of a vector that we have covered in our previous topic. So in this today's lecture we are going to start with accessing the elements. So that means our vector is now kind of well established, it is already created, and now what do we want to do is we want to access the elements. And in the beginning of in the beginning of the topic of vectors, I told you that vector is nothing but actually it's a dynamic array kind of thing which you can resize dynamically or at the runtime. So when we talk about any data structure which is kind of or which is similar to arrays, so the kind of the strategy or the technique of accessing the elements is also kind of, we can say, similar. So just like arrays, your vector elements or elements of the vector can be accessed using their index. So index, we all are aware what is index is, and that index is to be written inside the square bracket, and as far as array is concerned, that square bracket is nothing but the subscript operator. And whatever operations we are going to discuss today, there is no kind of there are many ways, many duplicate many multiple ways, I can say, to do the same operation, but that multiple ways are differing, maybe their internal techniques or maybe in their speed or something of that sort. So what I am trying to say here is, there is not only one fixed way for one particular operation or all the operations which we are going to discuss today. There can be multiple ways for accessing for implementing the same thing. So as far as accessing elements is concerned, we can use their index inside the square bracket, which is the subscript operator, just like a normal array. So that method works well. It is also a kind of a fast method, but it does not check whether the given index exists in the vector or not. So what will happen if the given index does not exist in the vector? Then it will throw kind of a a runtime error. Then that exception has to be handled separately. So for both the situations, when we are sure that the index actually occurs, the subscript operator is going to work there, and if it is like that, that index does not exist, or we may suspect that this index may not exist. So there is another method which is using the method at, and then we can use method at and safely access the elements without having kind of possibility of getting our program into a runtime exception or something of that sort. So with the help of very small code snippet, we will look into how to use these two methods. So here we have that code snippet on the screen. So we have integer main and all those standard C++.h and using namespace standard that you all are aware. So I am just coming to the definition of the vector. So a character vector named as V has been formulated, which is having 5 characters A, C, F, D and Z, and if we want to access and obviously print the values using these indexes, we will be using the index along with the subscript element as it is given in the line C out V3. So, that V3 is the element which is F. So, 0, 1, 2. So, element at the position kind of third position starting from 0. So, 0, 1, 2 F will be there, and the next is C out V dot et. So, V is the vector, et method is being called with that, and within the normal parenthesis I have given the index number. So, in this situation, even if the index is not available, it is not going to give you a runtime error, it is going to give a message that this particular index is not available, while the subscript method is not so safe if we are not sure that whether this index is available or not. So, in order to access the elements, we have two methods. One is using the index, or another one is using index within the subscript operator obviously, and the second one is which is being used as at. Then one operation is accessing the element, another one which is very kind of tightly knitted or close is updating the elements. So, updating the elements is kind of very similar to the accessing, except we are going to use one additional assignment operator through which we are going to assign a new value to that particular element which we are accessing. So, it uses the same method, the same two methods. One is the square bracket, which is the subscript operator, and another one is vector name dot 8 method. And how to update the vector elements? So, here that also we can look with the help of an example. So, similar vector I have taken, which is a vector of 5 characters, and now we are updating the values using the indexes, index 3 and index 2. So, here we are writing V3 is equals to T. So, that means the element at the index 3 is starting from 0 obviously. So, 0, 1, 2, 3, it is going to give it is going to replace the small d with the character D, capital D, and V dot at 2 dot is equals to the character F. That is also going to do the same thing. That means this small f is being replaced by the kind of the uppercase letter F, and then we can print in order to see whether it has been done or not. So, accessing the elements and updating the elements both can be done with the help of subscript operator and the method at. In case of updation, we need to use an assignment operator because we need to update the value. So, we will access and then update the value using the assignment operator. That's kind of we can say it's a pretty simple thing. Moving on to the next thing which is traversing vector. So, the the simplest idea one can think of is vectors in C++ can be traversed using indexes in a loop, and you are aware that index starts from 0 to vector size -1, which is kind of n minus 1, and to iterate through this range of 0 to size -1 we need to use a loop, and because size -1 I am talking about as the upper limit, we need to determine the size of the vector, and that size of the vector can be determined by using the size method. So, the first we will be looking into kind of size method. That size method will return the size of the array, and then we can use that as the upper limit, and both of these things are shown in the code snippet given on the screen. So, similar character vector we have used, which is having A, C, F, D and Z, and we want to traverse this vector using the vector size. So, the simple loop says as it is being shown on the screen, for integer I is equals to 0, I less than V dot size, and V dot size here is basically your kind of an function which is being used. So, V is the name of the vector which we have developed, dot size, and then we have, in order to move the counter variable, we have used I plus plus. So, as you can see on the screen, it is given as for integer I is equals to 0 till I is less than v dot size. So, this v dot size will kind of return the value 5 here. So, I is starting from 0, I less than 5. So, that means it will go from 0 to 4, and then I plus plus, and every kind of element is being printed by using C out v of I. So, here we are traversing through a vector by using the size function, we can say. So, that is kind of one way to traverse through the vector. Another operation which is kind of important is insertion of elements. So, let us say we have already created a vector and now we want to insert more elements. So, there can be couple of methods. So, one method is the method insert, another method is the method pushback. Both are used for inserting the elements into a vector. Your insert method is going to take linear time wherever we want to kind of use the insert method, we can. But as far as pushback is concerned, that is going to do the insertion at the end. So, if we want to insert some elements at the end, those elements are to be pushed back into that vector. So, that is why the method is being named as pushback. Now, this pushback is much more faster time, because it is aware of kind of the last index, and after accessing the last index, it is going to take only a constant time, because it needs to just kind of increment the index and just push back the method. While your insert, as far as is concerned, that insert may have the value, the value can be inserted at the first position or maybe in the middle, anywhere inside the vector. So, that is the difference between the two. So, let us see how these two can be used. So, we have used here vector v with 3 elements, with the elements as a, f and d, and let us say we want to insert the element z at the back. So, we are going to say v dot push back. So, push, there is an underscore between push and back, because the space is not allowed between within the name of the method as per the standard naming convention. So, we said v dot push underscore back, and whatever is whichever character or whichever value we want to push back, that value is to be supplied as an argument. So, that is a pretty simple we can say function here. Then, if we want to insert something at a particular index, then the two values are to be passed within the insert function. First is the position where you want to insert the element, and another one is the value. So, if you can see the next statement that says v dot insert, and within the bracket there are two parameters. The second parameter is the character C, which we need to insert. The first parameter has to be a position. So, position is v dot begin plus 1. So, from wherever your vector is going to begin, by adding 1, but by adding a 1 to that v dot begin. So, v dot begin, you can assume that v dot begin is actually a 0, so 0 plus 1 is 1. So, at the index 1, we are going to insert this element C, and if you need to kind of look into the result of both the operations, that is v dot push back Z and v dot insert v dot begin plus 1 C. So, then you you can look into the accessing elements using the for method, which we have just seen. So, for integer I is equals to 0, I less than v dot size I plus plus, and then there is a C out. Then you can have kind of look into the output that Z is being pushed back at the end, and your C is actually now lying at index number 1. So, in order to insert the element, we can use pushback if it is to be done at end, and if it is to be done at any other position except the end, we can use the specific position, and we will be using it inside the v dot insert function. Now, what do we need to do is we need to delete the elements. So, in order to delete the elements, the first and the first function which is available is the function erase. As we have used v dot insert, we are going to use v dot erase also, but this method needs the iterator to the element to be deleted. That means the element which we want to delete, the iterator to that particular element has to be kind of is actually required by this function erase. How it is being required, that we will see. So, if only the value of the element is known, that we need to kind of look into the position, or we need to find the position of the element, because that position is also to be kind of given to the erase function. And for that we in order to find the position, or in order to find the location of the element, the function which is going to be used is find function. So, the find function will return the position of the element, and that position of the element is to be passed to the erase function along with the value of the element. As we have seen two methods of insertion, one is insert and another one is push back. The push back is when someone wants to insert a particular element at the end. So, for the deletion at the end, the vector method, which is pop underscore back, can be used, and as the difference between insert and pushback was there in the time complexity. So, pushback was actually a constant time operation, because looking for the element was not a headache here. The element is available at the last position, that is that is being kind of that's a well known fact. While if we talk about the insert has to be anywhere in the vector. So, insert is actually an linear time operation, while pushback was a constant time operation. Similar goes with the erase, which is actually a linear time operation, and if we want to do the deletion at the end, or the last element is to be deleted, we can simply use pop underscore back method, and obviously it is faster and it will take only constant time in order to implement in order to get implemented. Now, here you can see the program, or a very short code snippet which is available on the screen. So, this code snippet says we have a vector v which is having 5 elements a, c, f, d and z, and if we want to delete the last element z, we will simply say v dot pop underscore back. Now, this after using this pop underscore back, we are having only 4 elements which are a, c, f and d. Z is obviously kind of being deleted or erased from here. Then we have for integer I is equals to 0, I less than v dot size I plus plus. That means here I am trying to access the elements, and I have already told you the output that the only 4 elements a, c, f and d are there. Z is already being kind of removed. Now, let us say if we want to kind of delete more elements. So, we can use v dot erase, but this v dot erase is actually looking for the position of the element which you want to erase. So, the element which we want to erase is f, but as we are not aware of the position, we will look for the position in the using the method find, and this method find is taking the parameters v dot begin and v dot end. So, starting from v dot begin till v dot end, the position of the element f is to be kind of looked for, and then that position is being passed as the parameter to the erase. So, find is going to take 3 parameters. One is where to begin, another one is where to end, and third one is what to look for. So, if we can see the find method clearly, that says v dot begin comma v dot end and then the element. So, from starting from begin to end, the element which is to be looked for is f, and this find method is going to give you the position of the element, and then that position is actually being passed inside this v dot erase. So, let us say v dot erase we say 3. So, the position is 3, and so starting from 0 1 2. So, third character which is f is going to be deleted. So, in this way you can use v dot pop back if you actually want to delete the only kind of the last element, and if we are actually not aware of the position of the element, we need to find that position using the find method. The find method will return the position of the element, and then that position is to be kind of passed as an argument to v dot erase, which will subsequently erase this element. And then you can by using that for loop for accessing the elements starting from 0 to v dot size, we can use that method in order to verify the results, that whether the particular element is being deleted or not, using pop back and using erase both. Now, apart from these kind of basic operations which we have seen is in the 2 lectures which is about the creation. So, we have seen 8 ways of creation. Then here in this lecture we have seen insertion of the elements. We have also seen deletion of the elements of the vector. We have seen how to access the elements of the vector, and we have also seen how to update the elements of vector. These were kind of we can say a very basic operations which are required to be implemented upon any of the we can say data structure. So, these are basic operations. Apart from these basic operations, we have kind of a list of other operations which are very useful in some of the situations. One such example is how to check if a vector is empty, and here obviously we are talking about C++. So, we have in order to check that whether the vector is empty or not, we have a function that is empty, and this empty is going to return the kind of a value which is a bool value. So, in order to use this function, we can have a look on this code snippet. So, if we want to check that whether the vector is empty or not. So, initially we have just declared a vector, no initialization is being done. So, that means vector is essentially empty, and if v dot empty. So, v dot empty is going to return 1 if actually this v is empty. So, here it is. So, this will print empty, else it will print non-empty if v dot empty is going to return a false value, we can say, or a value which is kind of a a 0 value, we can say. So, in this way we can check if the vector is empty. So, the simple and the another idea of checking whether this vector is empty or not is using the size function. So, we can also modify our code snippet and write if v dot size equals to 0, then it will print empty, as it will print not empty. So, the two functions for checking whether it is empty or not is, one is v dot empty, another one is using v dot size. If v dot size is returning 0, so we will compare the result of v dot size with 0. So, if v dot size is equals to 0, we will say empty, else we will say not empty. So, v dot size and v dot empty, that means the empty function and the size function are the two functions which are going to be used for checking whether a function vector is empty. Another way of checking whether the vector is empty or not is if v dot begin is equals to v dot end. So, begin and end, if both are equal, that means there are no elements. So, this we can use this as it is written on the screen. If v dot begin is equals to v dot end, obviously both are the functions. We will write C out empty, else we will write not empty. So, here as I told you in the starting of this lecture, that in order to do or in order to perform one particular function or one particular task, there can be multiple ways. So, here in order to look into that whether the vector is empty or not, we have used the empty function, we have also used the size function, and we have also used the function begin and end. So, in this lecture we have covered all the basic operations regarding vectors, and we have also seen one more task of looking into that whether the vector is empty or not. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed the lecture. More onto the vectors in our upcoming lectures. Till then, take care. Goodbye.